Hi, Miss Zaritsky here. I've always wanted to do one of these little videos. I always thought I'd be a good YouTuber, but I'm gonna go for it. And I want to share some information with you guys. And I put out the assignment on PictoChart and gave you some information on what's called a geologic timeline. And so we're gonna go ahead and we're gonna start with 4.5 billion years ago. So you guys have to know Earth's history in order to understand, what's going to happen. We got with some crazy times going on right now, and I want you guys to think about where the Earth was and what it could possibly turn into. So, 4.5 billion years ago. Big Bang! Hydrogen turned into helium. We know that powers the stars. We know we got the moon, from the Earth and all our other planets, along with our celestial bodies. And so that was the start of our universe. I would like you to consider how this happened. Share some videos with me. If that's something that you want to, check out, please let's start some discussion with this. This is cool. Then we can get like some conversations on Google Classroom and stuff. So let's think about what's the meaning of life? Where did we come from? What is this all about? So here's what happened. So the timeline is kind of like a math timeline. And in the middle, you're going to have 0. You're going to have positive numbers on one end. You're going to have negative numbers on the other end. But in this case, of course, there's no negative numbers. It's just that we just have this really long period of time. So think 4.5 billion years ago. And think like, okay, Big Bang happened here and the time is 0. Well, that first 500 million years, like, oh my gosh, I can't even think of like 2 years ago. Oh my gosh, I was in 6th grade, I don't even know. But first 500 million years, so a lot of time, right? And there's volcanoes that you see there because that's how Earth was. It was like Venus. It was just volatile, violent place. Our atmosphere was not so pleasant. It was kind of acidic. And so we wouldn't be able to survive there. Sorry, you hear my dog going off. Apologies. So volcanoes, if we've got volcanoes going off today, which we do, that's a normal thing for the Earth, what kind of carbon dioxide is it spewing out into our atmosphere? And if volcanoes caused our first 4 mass extinctions, a mass extinction is when like an entire species dies out. And we would never see it again. So if we've had 5 mass extinctions in Earth's history, 4.5 billion years, and we're on the verge of another one, not because of the coronavirus, but because of the pollution. And that's why I gave you guys that assignment about, what's going on with pollution now, because we are seeing that Earth is starting to repair itself because people aren't in their cars so much and burning fossil fuels. Fossil fuels are made out of carbon. Carbon dioxide interacts with our 21% oxygen in our atmosphere. So where did life come from? In all those One Strange Rock episodes that I would show you guys that you totally ignore, it talks about prokaryotes. So prokaryotes are just a one-celled organism. Think about it. Would this coronavirus be a prokaryote? The answer? Valley, because a virus is not really alive. It has that RNA and DNA, but not necessarily the functions to maintain their body temperature, reproduce, but they take over other cells. It's kind of a different thing. So bacteria is going to be considered a prokaryote. I don't know if you guys ever got the opportunity to look under a microscope. I'm going to put a little pond link on Google Classroom so you can see how small life is in pond water, and that is a prokaryote. So they existed 800 million years. Okay, so we're at 0 time. We went 500, actually we're at 800 million years, okay? No, sorry, 500 million. 500 million years and then 800 million years. So now we're going back. So this is what life used to look like. This was it. That's what we knew to be. Now you might be thinking, well, how did we know? Well, because we have like fossils and imprints and these things called molds and casts and mineralization and there's a whole bunch of chemicals that go into that, but there's evidence. So as time started to go on, though, life did start to change, and that was what I wanted you guys to see in your geological timeline. So, you know, organisms are changing all the time. That's called evolution by mutation. What characteristics are going to allow them to survive in that environment and what aren't? These anglerfish, like in Finding Nemo, have the little light that hung down. That's called bioluminescence. That gives that organism the ability to glow. Well, what good does it do for that organism? Well, it lives so down deep in the depths of the ocean that there's hardly any light, and that gives it the light that it needs. So, yeah, when did that come about? And please, like, if you're interested on what other kinds of organisms live in the ocean, you type into Google, you know, strange creatures in the abyss, ABYSS, abyss. That's the way deep down depths of the ocean. So we went from the single-celled organism, and now we're going to go into what are called multicellular organisms, and that is you. Because you have eukaryotic cells, so you're a multi-celled organism. Pangea Tamara. So anyway, okay, Pangea was all the continents put together in one. So imagine, gosh, if Earth is a ball, Earth would kind of be lopsided with land on just one side of the Earth there. So imagine 70% of the Earth, which it still is today, is covered in ocean. So we are now spread out, and that's how Earth is changing, because Florida is getting swallowed up by rise in the ocean levels, and land masses change, and that's what you guys should have learned about plate tectonics. All right, so now we're getting a little like closer in time. Okay, so it's 150 million years ago. So we're starting to see dinosaurs, and now, I mean, imagine we went from these really small organisms, and now we're in these really huge ones. Do you know how tall a chicken's ancestor was? Take a guess. Like, think about it in your mind. How tall was a chicken's ancestor? It was huge. It was like 8 feet tall. It's huge. Look into that. It's called a ditramina. Ditramina. If you're interested in that, check that out. Oh, we can have a whole bunch of fun. Whatever you guys are interested in, this is the time for your education, to where if you're interested in something, you let me know, or your teachers, your lovely team of teachers. Aren't you guys glad that we changed the name Fortnite? Or do you still glad that we have? Okay, never mind. All right. So 30 million years ago. Okay, so now all this time has passed. 30 million years ago. 30 million years ago. Imagine like if you had $1. Okay, that would be like a year. Now imagine if you had $10. Okay, that's 10 years. Imagine if you had $100. $100 is like a lot. 100. And then if you had $1 million, that's a lot. Now imagine $30 million. I can't even imagine it. So that's a lot of years ago, right? So this little chart that you see here, it just kind of shows, it's called a dichotomous key, and it shows how the characteristics of organisms start to change. So there's this guy, his name is Charles Darwin, and we'll talk, I'm going to make these little videos. Give me some requests. Tell me what kind of video. Well, within reason. So, dichotomous key shows how these organisms are going to be changing. How is it that a pine tree is related to like a jasmine plant that has a bunch of fragrance? If you would like to watch this video, I don't know if you can click on it, but you can totally type it in and check that out. I'm going to have to do 2 videos because this only goes to 15 minutes and you guys know I could talk. So here's our mass extinction. This is a geologic timeline. It just looks a little bit differently. It's not horizontal and linear. It's kind of a spiral just to show that a lot went on during this time. Okay, so all this time, boom, 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 boom. 4.5 billion years ago. Well, it's actually like 17,000 years ago. You know me and my math. Anyway, cavemen, the point is, imagine $17,000. It's a lot less than $1 million, but it's still a lot of time. That's when we started to see our Neanderthals and our Homo sapiens and Homo erectus and all those guys. So now I want you to imagine, just imagine, the Earth, if we said the Earth is 4.6, we're going to round it up, okay, 4.6 billion years old. And we're going to say, okay, we're going to take all that time and we're going to put it into 46 years. 46 years. That's almost how old I am, okay? So 46 years, humans have only been here for 4 hours. I want you to kind of really process this. Humans have only been on Earth for 4 hours. Remember that industrial revolution we talked about with the peppered moths? I'm so glad we were able to do that activity because now you guys understand it. So when we did that, that happened, imagine, a minute ago. That wasn't that long ago in time. And yet, we have destroyed half of the Earth's forests. That's how the whole Australian fire even came about, because we had to deforest for product. Yeah, it's quite a shame. So, I want you to kind of think about that also, because that was one of the questions I asked you guys. How is the virus affecting pollution? Now, what you should have responded with is pollution is actually minimizing. It's getting less. Why do you think that is? Because everybody is staying in their house because the quarantine. So no one's burning their fossil fuels and burning coal and burning oil. Well, there's still people out there, yes, but they shouldn't be. So it's supposed to be a lot less. So I'd like you to kind of check that out. So you would look at, how has the Earth healed through the coronavirus? And by healing, we mean that there are several layers of atmosphere. And as we've had this industrial revolution and those carbon dioxides have been mixing with our oxygen and in the atmosphere, they've made these chemicals called chlorofluorocarbons. And they are not good for us. So check that out. I'm going to end this video and I'm going to get started on the next video. I don't know how long it's going to be, but yay. See you soon.